Consider a digital logic consisting of 3 2 to 1 multiplexer M1, M2 and M3. And M3, X1, X2 are input of M1 clearly. X3 and X4 are input of M2. A, B and C are select lines of M1, M2 and M3 clearly. For an instance of input X1 is X2 1, X3 X4 0. The number of combination of ABC that gives you output Y1. If we will take three variables A, B, C, how many total combinations will be there? Three variables are there. So from three variables you can get total 8 combinations. 2 to the power 3. Out of three variables you will get total 8 combination 0 0 0 0 0 1 0 1 0 1 0 0 1 0 1 1 1 0 1 1 1 0 1 1 1. Total 0 to 7 8 combination will be there out of three variables, and they are asking out of 8 combination for how many combination this output Y will be 1. If we will fix x1 x2 at logic 1, x3 x4 at logic 0. So this x1 x2 is permanently at logic 1, this x3 and x4 is permanently at logic 0. Let us solve this. If this x1 x2 is at logic 1, so for a is equal to 0 as well as for a is equal to 1, this q1 will always be at logic 1, because if select input is 0 then x1 will be selected, i0 will be selected, x1 will be selected, and x1 will be selected and send it to output. So output will be 1. If a is 1 then x2 will be selected and x2 is also 1, then therefore output will be permanently at logic 1. This M1 mux will always produce output 1 if both the inputs are at logic 1. You can solve this by also expansion method. Okay, how? S1 bar into I naught is 1 plus S1 into I1 is also 1. This is the expansion method. When S1 is 0, I1 will be selected, I1 is x1 is 1, I naught will be selected, okay, and I naught is x1 is 1. When S1 is 1, I1 will be selected and I1 is x2 is logic 1 into x. S1 bar into I naught plus S1 into I1. Now this will be S1 is basically A. So A bar into 1 is A bar, A into S1 is A into 1 is A bar plus A is 1. So output will always be at logic 1, because when A is 0, I naught will be selected and output will be 1. When A is 1, I1 will be selected and output will be 1. So output will be permanently at logic 1. Whether, because you will put A as 0 or A is 1 at a time. Okay. So output will always be at logic 1. Here output will always be 0, because when B will be 0 then x3 will be selected and output will be 0. When B will be 1, x4 will be selected and output will be 0. Let us expand it. S1 bar into I naught is 0 plus S1, if this is S1 and this is S2, S2 bar into I naught, S2 is B and B bar into 0, S2 into I1 is also 0, so this will permanently 0. So this mux, the output of mux M2 is permanently 0, the output of mux M1 is permanently at logic 1. So whether you will put value of A 0 or value of A 1, output of this mux M1 will always be 1. Whether you will put value of B 0 or B 1, output of this mux Q2 or mux M2 will always be at logic 0. S2 bar into I naught plus S2 into I1, 0. Now they are asking for how many combinations output Y will be at logic 1. When output Y will be at logic 1, this input I naught is permanently at logic 1 for this mux M3, and this I1 of M3 will be permanently at logic 0. Why? Because this mux is permanently producing output 0, this mux is permanently producing output 1, and therefore this I naught input will always be at logic 1, this I1 input will always be at logic 0. So when the output Y will be 1, for getting output Y to be 1, I need to fix the value of C at logic 0, because as soon as I'll put the value of C to be 0, it will select I naught and value of I naught is 1 and output I will become 1. If I'll choose C as 1, if I'll choose value of C to be 1, then it will select I1 and I1, as I1 is 0, then output Y will become 0. So for output Y to be 1, for output Y to be 1, C must be 0. A must be anything, B must be anything. Why? Because either you will put A value 0 or A value 1, you will get 1 here. Either you will put B 0 or B 1, you will get 0 here. Okay. But to have output Y 1, you need to put the value of C to be 0. If you will put value of C to be 1, output Y will not be 1. So for Y to be 1, C has to be 0. A and B could be anything, because it is independent of A and B. Okay. So for how many combination C will be 0 out of these 8 combination? Let us write down A, B, C. 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 and 1 1 1. Total 8 combinations are there of ABC. For 4 out of these 8 combination, for 4 combination C is 0. C is 0 for out of these 8 combination. There are 4 combination in which C is 0, and value of AB is AB doesn't matter for output Y to be 1. Only C should be 0 for output Y to be 1. So in out of 8 combination here, in 4 combination C is 0, and for this 4 combination output Y will be 1. You can check it here. You will put A 0, B 0 and C 0. For A 0, this x1 will be selected and this will be 1. For B 0, x3 will be selected and this will be 0. Here 1 and 0. And C is 0, and then it will select I naught and 1 will be there at the output. For this combination 0 1 0, A is 0, it will select 1 from here. B is 1, it will select 0 from here, and this will be 1 and this will be 0, and C is 0 and this will select 1 from here, and output Y will be 1. For combination 1 0 0, for A to be 1, this will select x2 and output here will be 1. For B to be 0, B 0 will select what? This x3, and this output will become 0. So from here there is 1, from here there is 0, this is 1 0, and as soon as you will put C 0, it will select I naught and send the output Y to be 1. Okay. For 1 1 0, A is 1, it will select 1 from x2, B is 1, it will select 0 from x4, and therefore again it is 1 and it is 0, and as soon as you will put C is 0, it will select I naught and output Y will be 1. So for these 4 combination, for this combination output Y will not be 1. 0 0 1. Let us check this one combination 0 0 1. For A 0, it will select x1 and this output will be 1. For B 0, it will select x3 and this output will be 0. So here 1 and here 0. From this 0 0, A and B 0. And as soon as you will put C1, it will select this I1, and as soon as as 0 is there at I1, output Y will be 0, output Y will not be 1. So out of these 8 combination, in 4 combination C is 0, and for output Y to be 1, C must be 0. A and B could be anything. A could be 0, A could be 1, B could be 0, B could be 1. It is independent of A and B. So in out of 8 combination of ABC, in 4 combination C is 0. Therefore for 4 combinations, output Y will be 1 in this mux combination. So there are 4 combination for which output Y will be 1. Okay. So with this we have finished the discussion of digital electronics questions asked in GATE 2024 examination in CS branch. Thanks you so much. We'll meet with some other discussion. Till then, bye bye. Take care.